Hi, everyone. I hope you had a good spring break. So as you can see, I did finish grading all of the midterms. So if you have any questions about any of those grades, or you want to see more details on that, you can always reach out to me, and I'd be happy to find a time to meet with you to go over anything you may have missed on the midterm. But in today's video, I want to talk about variation equations. So to start with, let's take a look at direct variation equations. So a direct variation equation is of the form y equals kx. And k is a constant value, okay? So typically in these problems, we're going to be trying to find k, and then maybe we want to use the equation we create after finding k to find other values from the direct variation equation. Okay, so here k is a constant, and that's usually our goal is to find that. All right, so one of the things that you notice from direct variation equations is as x gets bigger, y is also going to get bigger. Okay, and as x gets smaller, y is also going to get smaller. So let's look at a couple examples here. So here we have, suppose y varies directly with x. We have y is equal to 3 when x is equal to 24. Okay, so we know that we're looking for a direct variation equation because it says y varies directly with x. So we know that it's going to be y equals kx. Okay, so if we want to find what k is, all we have to do is solve for k. So to do that, we can divide both sides by x, and we get that k is equal to y over x. Now we also have that y is equal to 3 when x is equal to 24. So if we want to find k, all we have to do is plug those two values in. So we can write this as y equals 3 over 24. Okay, and that's going to give us, after we reduce, 1 over 8. Okay, so here k is equal to 1 over 8. And therefore, our equation is going to be y equals 1 over 8 times x. Okay, that is our direct variation equation. Okay, so let's see what this will look like when we plug in values. So if we have x is equal to 2, that's going to give us y equals 1 over 8 times 2, which is equal to 2 over 8, which is just 1 over 4. Okay, so if we pick a bigger value for x, maybe we'll pick 16. We'll have x equals 16. That's going to give us y equals 1 over 8 times 16, or 16 over 8, which is just 2. Okay, so as you can see, as we plug in bigger values for x, the value for y is going to increase as well. Let's look at another one. Okay. Oh, I must have copied the same. I'll make something up here. We'll say y equals 1 when x equals... let's try something different. Let's do y equals 10. When x equals 4. Why not? Okay. So here we have y equals kx again. Okay. So if we want to solve for that, we already have k is equal to y over x. Okay. So we can just plug in our values for y and x. So we get 10 over 4, and we can reduce that to 5 over 2. So our direct variation equation is going to be y equals 5 over 2 times x. Okay. Here we have y varying directly with x, where x is equal to 18, or so y is equal to 18 when x is equal to negative 3. So here again, we have that k is equal to y over x, which is going to give us 18 over negative 3. And 18 divided by 3 is 6, so 18 divided by negative 3 is going to be negative 6. So k equals negative 6, and therefore our direct variation equation is going to be y equals negative 6x. Okay, and so you can do this for anything. Well, once you're given that it's a direct, if the relationship between x and y is a direct variation relationship, it's pretty easy to find the general equation for it, okay? So another type of equation that we have is the inverse variation equation, okay? And this is kind of the opposite of a direct variation equation. So this is going to be of the form y equals k divided by x. Last time we had y equals k times x. This is equal to k divided by x. And again, we have k is a constant value, okay? So it's some constant that we're trying to find usually, okay? So what this means is that it's the exact opposite here. Since we're dividing by x, as x gets bigger, we're dividing by a bigger number, right? So if we're dividing by a bigger number, that means that x is, as x gets bigger, y is going to get smaller, okay? So this is the opposite of the direct variation equation, right? So, and conversely, as x gets smaller, or at least as x gets closer to 0, you can think of it that way, you're going to have y getting bigger. So it's the exact opposite here, okay? So let's take a look at a couple examples. Here we have, we're going to suppose that y varies inversely with x, and we have that y equals 4 when x equals 6. Okay, so if we go back up here, we can solve this for k. So we have y equals k over x. So to find k, we multiply both sides by x, and we have k is equal to y times x, okay? So here in this case, to find k, we have k is equal to y times x. We had y equals 4 when x equals negative 6. So we have 4 times negative 6, which is going to give us negative 24. And therefore, because our equation is of the form y equals k over x, we're going to get y equals negative 24 over x. Okay? So let's see what happens here. Let's start with a fairly small number. If we have x equals 1, okay, we're going to have y equals negative 24 over 1, which is equal to negative 24. Okay? Okay, that's fine. But what about x equals, I don't know, 12. So x is quite a bit bigger now. We have y equals negative 24 over 12, which is just going to be negative 2. Okay, so y is getting smaller, or at least closer to 0, right? Y is getting closer to 0 as x gets larger. Now, what about when x gets smaller? Okay, if let's say we have x is equal to, I don't know, 1/2. 1/2. If we have x is equal to 1/2, we're going to have y equals negative 24 divided by 1/2. And this is the same thing as, remember, if we divide by a fraction, where it's the same thing as multiplying by its reciprocal. So this would be negative 24 times 2 over 1, which is just negative 48. Okay, so we can see that y gets further away from 0 as x gets smaller. Okay, and as we get closer and closer to 0, you're going to see that x is going to get very large very quickly. Okay, let's do one more. Suppose y varies inversely with x, and y is equal to 3/4 when x is equal to 24. Okay, so remember we have y equals k over x. Okay, and remember we can find k as k equals y times x. So in this case, we're going to have 3 over 4 times 24. So we can go ahead and reduce the 24 over 4. That's just going to be 6, right? 24 divided by 4 is 6. So this is the same thing as 3 times 6. Okay, that's going to give us 18. So k is equal to 18. So our direct variation equation is y equals 18 over x. And you can play around with this one as well if you want and see what it looks like, okay?